So in this video, we are going to work with polar numbers. We are going to learn how we can multiply them, for example. Share slides with you, share conference, this. Okay, annotation, here. Okay, have a look, guys. In polar 4, simply, we cannot add two polar numbers. If you are given two things like this, 1 minus 30 plus 2, 45, you cannot directly add them up. If you are given 2, 45 minus 2, 30, you cannot do that in polar 4. It's impossible to do so in polar 4. No direct way. First, you need to make it Cartesian. Then in Cartesian form, you can add them up. For example, here 130 plus 2 angle 45. We are going to add these two up. So 1 angle 30, it's going to be 1 cosine 30. It's the square root of 2, the square root of 3 over 2, excuse me, as the real part. Then J 1 by sine 30. J sine 30 is 1/2. This is going to be the first one in Cartesian form. The second one in Cartesian form, 2 by cosine 45. 2 by a square root of 2 over 2 is going to be a square root of 2. J, in order to show it's imaginary, then 2 times cosine 45. You have two numbers, two Cartesian numbers. Real goes with real. Real with real. Imaginary with imaginary. And then after adding up those two things, you can make it polar if needed. 130 minus 245. Again, let me do this. Let me stop sharing and do the second one for you. Here, question is this. 130 minus 245. First of all, I need to make 130 Cartesian. It's 1 cosine 30 plus j sine 30. Excuse me, minus this part. 2 cosine 45 plus j 2 sine 45. Cosine 30 is square root of 3 over 2 plus 1/2 g minus 2 by square root of 2 over 2. The other part is j 2 by square root of 2 over 2. These two cancel that, these two cancel that. So it's going to be square root of 3 over 2 plus a minus the square root of 2 as the imaginary part, as the real part, excuse me, plus j. Now let's go over imaginary parts. 1/2 plus square root of 2. Negative. This negative must be multiplied by 2. Here it's going to be negative. Here it's going to be negative. So, guys, now look. There is a negative here that goes to this and that. This and that. This and that. Okay. So then you can leave it just like this, or you can use your calculator to find the final value. Let me go over the product. So you have learned polar is not a good thing for sum or subtract of two numbers. But how about multiplication? You remember, for multiplication of two Cartesian numbers, we need two distributive method. This by this, then this by that, then the other by the first one of the second, then the second one of the first parenthesis by the second one of the second parenthesis, something like this. Let me write it. A plus bj by c plus dj is going to be ac, the first of the first, then the first of the second, then the second of the first, j ec, and then second of the first by second of the second, which is negative bc. Okay. However, now look at this and see how easy you can do that. In polar format, when two numbers are multiplied, how you are going to find the product? Simply multiply the amplitudes, the lengths, amplitude, okay, the word. A stands for amplitude, A theta, or R theta. A stands for amplitude. We're going to call it amplitude. Amplitude of the first one by the amplitude of the second one. It's going to be simply AB, just a product, simple product. And then add up these two thetas. Here, example. 130 to 45. 1 by 2, 1 by 2. Let me start annotation. Here, 1 by 2. This one by that 2. Then 30 plus 45, 75. So fast, so easy. How about division? Division in Cartesian form was really hard. That was a pain on neck. That was really, really hard. First of all, you need to get rid of all of the j's in the denominator and just consider a situation like this. 1 plus j over 2 plus j by 1 minus j. In this form, one time you need to multiply both numerator and denominator by 2 plus j's conjugate. Then one time multiply both numerator and denominator by 1 minus j conjugate. It's going to be a long way to go, but have a look and see what happens if you are going to do that in polar. A theta over b beta, just a by b, the amplitude of the numerator by the amplitude of the denominator, then theta of the numerator minus the theta minus the angle of the denominator. Here, have a look at this example. 130 to 45. Simply, the amplitude is going to be 1/2. And then 30 minus 45. And this is going to be the answer. Half, negative 15. Angle, negative 15. See how simple is that in polar form? Polar form is good. Let me stop sharing. We have Cartesian, we have polar. Cartesian is the only way in that we can add and subtract. Also, we can do division and product, however hard. Here, no add, no subtract, but easy, super easy division and product. So when you are dealing with these numbers, whenever you are going to divide, it's better to go over polar form. I have a question for you. What is J in polar? J means 0 plus 1J. What's that in polar? Just imagine this. Where is J? Is this going to be J? Is this going to be J? Is that going to be J? Or this one is going to be J? Which one? J is simply this. This is vector J, correct? What's this angle? 90. How long is this? 1. 190 is J. So simply, whenever you see, for example, J by 1 plus J, you are going to do this product. For product, you can simply say 190 as J is, imagine the location of J, the square root of 2, 45. 1 plus J. 1 is going to be perfectly here. So it's bisector here. 1 plus J is bisector. So this guy is 45. And the size is the square root of 1 plus the square root of 1 plus 1. So square root of 2, 135. 1 over J. 190. 1. Where is 1? Show me that one. Try find that one. You cannot show me right now. But where is 1? 1 is this. In polar form. 1, 0. It's a vector with angle 0. 1, 0 over 190. 1 over 1, 1. How about the angle? 0 minus 90. So 1 minus negative 90. Do you remember I've told you 1J is equal to negative J. You can transfer this over or under the line by flipping its sign. So 1 over J is negative J. Where is negative J? It's going to be negative J. Where is 1? Negative 90. Negative 90. 1 negative 90 or 1 or negative J. 1 over J, 1 negative 90. 1 over J, negative J. See? Actually, you need to imagine where these numbers, where these vectors are going to be. When someone tells you 1 plus 2J, you can guess where is it? 1, 2. It's going to be a vector like this. This theta is for sure larger than 47. Okay? It's going to be larger than 47. If you are going to find that, use your calculator. Inverse tangent of 2 over 1. But this is very useful. This imagination is very useful. All the time find where that vector places. Let me bring so. So this is enough for this video. In the next video, I will solve examples for polar form.